13 hertz. We are giving it the 13 hertz input, and we are recording the data for 5 seconds. Here we can change for any time. We can record the data, but we are recording it for 5 seconds. Okay. So just give them. See here, this is the data which we got. The red one is the output, okay, and blue one is the input. Okay, as we are just giving at the constant frequency, so there is no need to see the FFT. We'll give the sine sweep input. At that time, we'll see the FFT, so that we can get the resonance condition. Okay, this is the output and this is input. This data we can just copy all the signals data in Excel, and anywhere we can plot it, and we can also do the signal processing, which I will also tell, because these are having some noise. You can see it is not exactly sine wave. I will change this range. I will change to suppose 2 seconds. Now you can see they are having this not exact sine wave. Okay, they are having some noises. This will we'll take this data in MATLAB, and then we'll do the signal processing, so that all the noises we can just eliminate. Then we can get the proper sine wave. Okay. Now we'll increase the frequency, or just decrease it to 10 hertz. Check the explanation. Now you can see we have decreased the frequency, so input and output, they are approximately coming same. The output is the red one, where the displacement is approximately equal to the input. As the resonance condition was about 20, I think 22 hertz.
How much should I put
22. Now you can see this is at the resonance condition. The red one is the output. It got increased. So the output oscillation got increased here. We can take, actually this is the time domain data when we are doing the analysis. This is the main data which we need to give in the research paper. From this data, we will take this data and we will calculate the transmissivity. We can't directly take the data from sine sweep. This is the main data which we can take. Now we will show you the sine sweep.
15 seconds from 1 to
20 seconds. 20 seconds.
20 seconds.
This is the excited. But in our case, our rotor is the system, right?
You can just change the, as we are performing the sine sweep for 20 seconds, so we have to change the input data. So we need to collect the data for 20 seconds. So in this software, we have that, we have the configuration to change the recording. It's recording time. Now it is for 21.843 seconds.
So can you tell sine sweep, what happens in sine sweep?
What happens?
Sine sweep.
Sine sweep is that we are giving the sine wave input from, suppose we are giving from 1 to 60 hertz in 20 seconds. So in 20 seconds the sine wave will go from 1 to 60 hertz.
Oh, you are increasing the frequency.
You are increasing the frequency
Understand, yeah.
from 1 to 60 hertz in 20 seconds. Yes. This we can see the results. The red one is the output. As you can see that as the input frequency increased, the red one got increased till here, and then after that it started decreasing. So here this is the resonance condition, and the same will come to FFT. Here you can see resonance condition. It came around 40 to between 40 to 50. Here you can see the maximum amplitude. In the same FFT you can see 40 to 45 hertz. The maximum amplitude is coming. It's not 40 to 45 hertz. We are changing the time. Which one?